All right, let's talk about motion. When you picture something moving, what do you see in your head? Probably something going in a perfectly straight line, yeah? Like a car on a highway or maybe an apple falling straight down from a tree? But what if I told you that in the grand scheme of things, straight lines are, well, kind of boring and actually pretty rare? Turns out the universe seems to be obsessed with curves.
I mean, just look at this. This one idea completely flips our simple picture of the world upside down. It's basically saying that everything we thought was the rule, straight lines, is actually the exception. And that, of course, leads us to the big question we're going to tackle today. Why? Why is that?
And this isn't some far-out abstract idea either. You see it everywhere, every single day. Just think about it. The perfect arc of a basketball swishing through the net, or the smooth, constant orbit of a satellite high above the Earth. You've got a swimmer diving into a pool, their body tracing this beautiful curve. Even something as simple as a car making a turn, that's curved motion. It's literally all around us.
So that brings us right back to the big puzzle. Why all the curves? Why doesn't nature just take the most direct path? Is it trying to be difficult? Well, to figure that out, we actually need to go back to the stuff you already know. We're going to build on the physics you're already a pro at.
That's right. The answer isn't some crazy new complicated thing. It's hiding in plain sight, right inside the physics you've already got down pat. So let's start with that solid foundation.
So, you've spent a good bit of time on one-dimensional kinematics, right? It's the physics of how things move in just one direction, along a single straight line. It's either going forward and back, or it's going up and down. That's it. It's simple, it's predictable, and it's super useful.
And honestly, you've got this mastered, for real. All the tools and equations you learned for that one-dimensional motion, that's basically all you need. To understand almost all the motion in the entire universe, we just have to add one tiny new ingredient to the mix.
So what is this magic ingredient? Well, here's the cool part. It's not really about adding something new. It's more about realizing that there have been two ingredients there the whole time, working together.
And here is the big reveal. This is so important. Moving into two dimensions doesn't mean you have to learn a whole new textbook of complicated rules. Nope. It just means you take the exact same rules you already know for one dimension and you just apply them twice, at the exact same time. This is it. This is the secret, the whole key to everything. An object's motion sideways, its horizontal motion, has zero effect on its motion up and down, its vertical motion, and vice versa. They are completely, totally separate. It's like they're living in two different dimensions at the same time, but for the same object. They just don't care about each other. Okay, so now that we're in on the secret, this whole independence of motion thing, let's use it to crack our first case, that beautiful arcing curve of a thrown basketball.
This breaks it down perfectly. Let's walk through it. So step one, you throw the ball, you give it a forward push. That's its horizontal motion. If there were no gravity, it would just sail in a straight line forever. But step two, at the exact same time, gravity is pulling it straight down. That's its vertical motion. And because these two things are totally independent, the ball does both simultaneously. It moves forward while it's also accelerating downward. And what do you get when you add those two simple straight line motions together? You get step three, a perfect curve, every single time.
And this idea is so incredibly powerful, it's like the source material says. Just by getting this one simple concept, this simple extension, we can suddenly understand and describe so much more of the world. It is a massive unlock that gives us some really deep insights into how nature works.
So now, with this new tool in our belt, we can finally go back and answer that first question we had. We're ready to stop seeing the world in simple lines and start seeing it in two glorious dimensions.
And here it is, the big answer. Nature doesn't prefer the scenic route. It doesn't have a preference at all. A curve isn't a choice nature makes. It's the inevitable outcome. It's physics. When you've got motion happening in one direction, say forward, and you've got a force, like gravity, acting in a different direction, down, a curve is the only path that can possibly exist. It's just a sum of two much simpler motions.
So let's do a quick recap. What are the big takeaways here? First, curves are the norm, not the exception. That's just how the universe rolls. Second, you don't need any new, scary physics to get it. 2D motion is really just two 1D motions happening at once. Third, and this is the most important part, the horizontal and vertical pieces are totally independent. And finally, that means curves aren't some deep mystery. They're just what you see when you combine those independent, straight-line motions.
Just this one little shift in how we see things, from one dimension to two, it completely opens up our ability to describe the world.